has trees, and a tree in machine learning world means a decision tree. Now if you haven't seen my decision tree tutorial, then you should click on that pause button right now, go watch decision tree tutorial and then come back here. Assuming you have watched this, what we try to do in that tutorial is predict employee salary based on certain features, and we build a decision tree like this. Now this decision tree looks very complicated, so can you represent it in a very simple image? Well, yeah, there you have it. You have green samples, red samples, and based on that, you build your decision tree. Now, how can you build multiple decision trees out of this single data set? Well, one approach is you take your data set, then you divide it into batch of random data sets, then you build decision tree for each of them. So since we did random sampling here, is called random forest, and now we have multiple trees. So you see a forest being formed already. Once it is trained, you give the thing that you want to predict and they will all come up with different decision. You just may take a majority vote out of it and get a decision. So this is the basic crux behind the random forest algorithm. And I recently used similar approach to make a decision in my real life. I wanted to buy Nest thermostat and I called bunch of my friends. And yeah, by the way, that's me in the picture. And those smart dudes gave me different opinions. One guy told me, it's gonna save you so much money. I saved like $500 last year, so you should buy it. The other friend say, oh, it's freaking $200. It's a waste of money. Don't buy it. Third guy told me, oh, you can control your temperature remotely anywhere from outside, so definitely buy it. All I did is just took a majority vote and decided to buy it. See, making decisions is so simple in life. Just call your friends and take a majority vote. All right, it doesn't work all the time, but at least in this case it worked and I had a decision, and I'm not making this up. I just installed it yesterday. All right, now we're going to use sklearn's digits dataset to make a classification using random forest. So that dataset basically contains the images of handwritten characters, and all you're trying to do is just classify into one of these 10 categories, where there is a digit from 0 to 10. All right, so that's what we will do in our Python coding today, and in the end we will have an interesting exercise for you to solve. As usual, I have launched my Jupyter notebook and loaded the digits dataset from sklearn datasets. All right, and if I look at the properties of this dataset, it has the real data and the target. All right, now I'm going to use matplotlib to visualize my data, and when I run this, it looks like this. So I have basically handwritten characters, which is like 8 by 8 pixel array. It's like a multi-dimensional array. And when I use matplotlib, it looks like this. You can see this is character 0, 1, 2, 3, and so on. Okay. Now I will create a pandas data frame from this data set. So digits data, basically data is, if you want to see it, just to make it simple, you will see that it is a 2-dimensional array of numbers. So let's look at first 5. See, first 5, like each element is just a 2-dimensional. It's actually 1-dimensional array, but it's like 8 by 8 matrix. So the length of this array is 64. Okay, and you can visualize this in a better way if you are using data frame. Each sample is nothing but an array of 64 integers, and they map to the target variable. So if you do digits.target, it is showing the target variable, and I'm going to append that into my data frame. This is how you create a new column in pandas data frame. This is nothing but digits dot target, and when I look at my df.head, it says that this 64 samples, they map to 0. All right, so for example, this picture here is actually 0, so this target is showing you the truth. All right, now what I'm going to do is use train test split. So I will do from sklearn dot model selection import train test split. Once you import that, you need xtrain, xtest, ytrain, ytest, okay, and train test split. Now my x is just a set of independent variables. Now my df already has target, so I need to drop target from that. Okay, so I'm going to drop target, and axis is columns, and my y is digits.target, and you need to specify how you want to split your training and test data. When I say test size equal to 0.2, it means 20% of my sample is test data and 80% are training. Okay, when I run this, it created all these 4 variables, and when you look at size of your xtrain, it is 1437, whereas xtest is this. So this means 20% of your total samples. So now I have nice training and test samples. I can use now the random forest classifier to train my model. All right, so from sklearn dot ensemble. Now why is it called ensemble? Ensemble is a term used when you are using multiple algorithms to predict the outcome. All right, that's what we are doing here. We are building multiple decision trees and taking a majority vote to come up with our final outcome. So that's why it's called ensemble. From that, import random forest classifier. Okay, and then just call model.fit. This is your training step. After this step, your model will be trained, and it trained the model, and you can see a bunch of parameters here. So the Gini and entropy criteria is something that you studied in the decision tree tutorial already. So that's what this is. You also have estimators. So here 10 means it used 10 random trees. Okay, and we are going to see the performance using the 10 random trees. So let's call model.score on x test and y test, and we can see that the accuracy is 91%. Okay, when we use 10 random trees, the accuracy was 91%. Now let me try to tune this model, and by giving 20 random trees. So I train it using 20 trees. You can see my score is increasing. All right, I had more trees and my score increased. If I do 30, wow, it's even better. Okay, so looks like now it's not changing much. All right, so 40 or 50 trees, you can get a base score. So you can fine tune your model by tweaking this parameter. It also depends on your samples as well. So if I execute this line once again, then now my training set has changed, and it might give me a different result. So you see it performed even better now. Your model is trained, and you can give any sample input, which is nothing but this kind of handwritten character image, and it will tell you what number that is. All right, now I'm going to plot a confusion matrix to kind of see the distribution of errors and where my model perform well versus where it performed poorly. And for that, I need x predicted. So here I can use model.predict on my x test dataset and I get y predicted. This is predicted by model. This is the truth. Okay. And confusion matrix allows you to plot truth on one axis and the prediction on the other axis. From sklearn.matrix import confusion matrix, and I'm just going to call it CM. Here you first supply your truth and then you supply your prediction, and when you plot this, is gonna plot two-dimensional array. All right, now this is probably not a better way to visualize it, so I'm going to use a Seaborn visualization library. I'm just going to copy paste code just to save some typing. So it's the same confusion matrix, but it's visually more pleasing. Okay, so here you have your truth data, you have your prediction, and what this means is I had 46 0 and 46 time it predicted them to be 0. So for 0 it performed like really well. Now what does this 2 means? This 2 means I had 2 times the truth was 8, but my model predicted it to be 1. So this is where it made an error. 30 times the truth was 8 and it predicted it to be 8. Right? So this is a nice visualization which allows you to gauge the performance of a model, and you should use it more often. All right, now the most interesting part, which is an exercise. We are going to use our famous iris dataset from sklearn.dataset to predict the iris species, and for that we'll use a random forest classifier. So I want you to train your model using the default n estimated parameters, and then try to tweak it and tell me what base score you can achieve by using how many trees. All right, you should do this exercise. If you are not